Yeah, Manas, do you want to describe a little of your background?
Yeah, for sure. So, again, computer science undergrad from India, and I think for the last like 6 years or so, I worked in like AI machine learning, and I was an ML engineer at AWS recognition team.
Hmm.
This was like pre-GPT, so we were still like fine-tuning and training the basic models themselves and trying to productionize them and so on. So I have experience there, but most recently I transitioned into product. Did some work in India and then came for my MBA at UC Berkeley. And so I'm almost done with that. But yeah, I'm always like looped into like AI ML community, open source it's become my thing from
I
the time
love it.
I've been in, US, and that's how I got to meet Arise, you guys. And so yeah, I'm excited about the event.
Awesome. Yeah, and excited to have you here. We're gonna again jump into Manas did a pretty amazing, I would say, research piece on trying to see how well uh, evaluations of SQL generations actually is. So the materials, I feel like you went in really good technical depth, did an awesome suite of tests to understand how well evals work on SQL generation. And we'll jump in and we'll give it one more minute here for folks to trickle in as we hop in. Yeah, and we'll continue to. So some of this work actually went into there's now an eval in Phoenix that's SQL based templates. So that's now formal. We were kind of testing it in your stuff originally. So that's the SQL evals now in Phoenix, um, and yeah, this research kind of gave us the foundation that we felt good about the results from it. So why don't we hop in and kind of get going?
Sure. Let me share my screen. Okay, put it on a slideshow. Uh,
Great.
See it, right?
Yeah, I can see it.
I can probably do this. Okay. Um, I can start. Do we have
Yeah,
enough?
let's kick it off. And
Yeah.
I mean, maybe talk about like maybe start with SQL generation a little bit, which is like what we're trying to eval, like where would ever I see it all over the place, people are using it, but maybe set up the
Yeah,
where it might be used.
sure. I think, with the rise of like these co-pilots and virtual assistants, especially in like domains like finance, that's where I tried it out. I think a lot of teams are trying to see if you can use LLMs to generate SQL queries. So like, you just put in a prompt saying, hey, what was the revenue between so and so date? And then the LLM would take that query, and then it would have access to the database, and then also to like SQL query engine as a tool. And so it will take the prompt, analyze it, and then execute then create a query based on, what question you gave it. So that's there. And there's a host of LLMs now which are fine-tuned on SQL generation.
Hmm.
The one I used was SQL Coder. So this is by a YC startup.
Hmm.
And they created this open source this, and they trained it on like super specific SQL questions and queries. So, that's the one I use, but there are a lot of them on Hugging Face as well. People can go and, look them up too in the model section. Yeah.
Yeah.
Yeah. Yeah. So I guess in terms of just to give a little bit of a background on the experiment itself, I was working with Plino AI, which is a Berkeley Skydeck startup, and we were trying to build like a financial assistant, sort of a co-pilot. So essentially, you want to help like these private equity analysts, these financial stakeholders do their research better. And for that, they have a lot of like these databases like revenue data, and PO purchase order data and all these like company data they want to look at. And for that, we wanted to train a text to SQL model, and so that's where I use SQL Coder. But then when I came across like how do we evaluate it,
Yeah.
right? That was the first thing, that was the question in my mind. And so LLM as a judge approach was very popular.
Did
So
you did it work? Did it feel like it worked out of the gate? Like was it you felt like it was generally working, sometimes it wasn't, or what was the impetus to even think about like testing?
Yeah, I think LLM as a judge, it is very easy to try, first of all.
Yeah.
So, you can just like, and we'll talk about what the approach is, but it's very easy to try, but the results itself were very like, they weren't consistent.
Yeah.
You send in the batch one, it gives you some result. You send in the batch, next one, and then the LLM interprets the results in a certain way because of certain issues. We'll talk about them, but it's not consistent.
Yeah.
And we'll also argue that it's also not the most cost friendly. We can talk about that,
Yeah.
because you're using LLM in production to do these evaluations. So these were some of the issues why we thought, hey, let's think about it more broadly. And is this the right approach to do it? So
Cool. Let's hop in.
yeah, yeah. So now, just to give some context, right, how this came about. So first of all, like big kudos to the Arise AI team, Jason, and the whole team. Like I was part of the Slack channel, and I thought, hey, LLM as the judge is not ideal, maybe. And I came across some new evals we could use, and we'll come to what evals they were. But I just raised this like as an issue in the GitHub, and then just like Jason replied to it. And that's how, this whole experimentation on how to improve LLM as a judge started. So, big kudos to the team for just being so open. So that's how this sort of experiment started. But just let's take a step back. What is LLM as a judge approach, right? And if you guys have any questions, like feel free to like put them, in the Q&A, and more than happy to answer any questions. So it's pretty simple. You have, you have this like LLM, like I said, SQL coder, for example, which takes in like a prompt and creates a query, right? Now, but you want to evaluate whether this query is right or not. So to evaluate that, we can use, either you can do it manually, and that's time taking, or you can probably use like a judge LLM. It's like GPT-4 or Cloud or any big LLM. And you give it the query, you give it the question, and you give it the instruction, and like what it needs to do. So given that, it will tell you if the query was correct or not, meaning does it answer the question or not, you know. So and then you just like compare it with the ground truth, and then you see how good, your LLM as a judge is. But LLM as a judge is, you're using an LLM to trying to evaluate this another LLM. So, that's the approach.
Great. And I'm excited to kind of
Yeah.
see how well it worked.
Was that? Could you come
I'm
again?
excited to kind of see how well it worked, which is, I
Yeah,
think,
sure.
yeah.
Yeah.
And I think the challenges too are like the judging of this was one of the, some of the the judging of it, if it's correct or not. And like there's a lot of subtleties to correctness for the results from a SQL query. Like, I think that was kind of one of the takeaways of this. Like it's not as black and white as maybe some other things that you do.
That's right. And I think one of the big assumptions worth mentioning, and even in the let's talk about what prompt we gave this judge LLM,
Yeah.
right?
Okay.
Because I think that's important. So you just tell it to like, hey, there is the SQL query. We are giving you the SQL query, and you are tasked to evaluate whether it answers a given instruction, right? And you give it three things. You give it the question, which is like, what do you want to analyze? And then you give it the query, and you give it the response. Response is like, what was the output generated by executing the query through an engine? So that's the response. You give it all this, which is good. LLM has a lot. Our judge LLM has a lot of information, to to get this inference whether the query is correct or not. So that's good. But we're also taking some assumptions. The first
Yeah.
assumption is like, it assumes that the database exists, and the columns are appropriately named. So it doesn't have any information of how the schema looks like, So it's just thinking if the query logically follows the question or not, So it doesn't have that granular database information, which will be significant as we'll see. But this is the assumption.
Yeah.
Uh, yeah.
Yeah. And the first thing that pops in my mind is should you add schema? But I don't want to jump ahead.
No, I think that's a valid point.
Cool.
So yeah, do we like, I know we are, maybe I can just cover this too
Yeah.
before we take questions. So again, circling back to our initial discussion, right? Like how good is this approach, LLM as a judge? Like one, I think it is circular in a way that you're using a big LLM to evaluate a small LLM. And LLMs, we know like they're good at hallucinating with confidence, you know. So like they'll tell you that it's true and even give a good score to it, but you know, it's limited by what information you give it. And then again, we are not giving it the schema, as I said. The complexity is another interesting point. Like if you go right now to like Chat GPT, and if you ask it, you know, you ask it to write a query, almost always you'll see it creates like a, you know, like a very complex join with multiple tables and subqueries. You know, whereas if I or you or anyone who knows SQL will do it, there'll be a much more optimal sort of a query, right, that we will create. So I think, you know, that's another point. And then how good the LLM as a judge is to make that distinction, right? Complexity is something you know, which is critical, and then costly. You know, you're running this LLM as a judge again and again. So that's another. So these four were the reasons why I, in fact, like reached out, you know, to Arise and just like trying to see if we can have a new eval or something like that. I'll stop here for if there are any.
Yeah. And I can drop some questions. We're gonna go into like a little bit of like how Manas tested the results and dug in, and like you're gonna get a lot of data really quick here. But the first question was, what was the total inference latency on average? And I'm not sure if they mean inference of the SQL generation or the eval itself. I mean, the evals are decently fast. Like you can do 100 in a couple seconds, you know.
Yeah,
Um,
yeah.
there, yeah.
I would just add like, if you remember, Jason, like we discussed, like we could do an asynchronous call,
Mhm.
you know, to
Yep.
these to the judge eval, so that way the whole thing became faster.
Yep.
think- I think I ran like 200 data points, and with the asynchronous sort of a setup, right? I think it takes like a minute or two, you
Yep.
know, for that. But I'm sure I can optimize it further, you know. But
Yeah, so in the library, there's what Manas is talking about is there's an async IO. If you drop that in, and that's in kind of the examples within the library. We call out parallel wise to the evals. So and there's concurrency. You can decide there's a parameter. I can do 100 concurrent or 20 or whatever. So you can
yeah,
kind of like scale up the speed of the evals, up until you hit your rate limits on your key.
yeah,
Essentially, that's kind of the gating limit. The question is, instead of evaluating generated SQL, evaluate text in question before being fed into the LM may make more sense. One good question can make good SQL. Yeah, a good question. Can the question actually be translated to SQL is actually it's a good point. I mean, that probably is a type of eval in itself. Um,
yeah.
I was wondering, why aren't we evaluating the output of the query with the ground truth output like we do CodeGen LLM?
Yeah, I mean, I think that's what we will do, you know.
Yeah.
So that's where, you know, given these issues, so that's a good segue to into the
Yeah.
next thing. But we will, you know, we will create, or we have some like ground truth data, like SQL queries, and we'll compare it against those. So yeah, that's
So
a
why don't you hop in, and we'll take the other questions in
sure,
another slide here. Yeah.
sure. So this is like notes from me and Jason. We were like brainstorming, you know, on hey, if LLM as a judge is not ideal, you know, what else can we do, and how can we compare how good LLM as a judge is, right? We need a number, you know, to like say, hey, this is the accuracy of LLM as a judge approach, right? So in order to facilitate that experiment, in order to understand how good that approach is, what we did is this. So, you know, we created like a golden data set. Not we created, we had it from open source. So Defog is the same startup that created SQL Coder, and they also had like a golden question and query data set. So question and query, they have it. And they have like really optimized queries. So essentially what you can do is you have your golden question, you pass it through your LLM SQL generator. Now, this is a separate LLM, right? This is not your LLM as a judge. And just to make the distinction clear, we're talking about a lot of LLMs here. This is your SQL coder LLM. So you pass this question into this, and then, and then what happens is it creates a query, and then you execute that query and you create a database, right? So essentially the output of what will happen once you execute this query. So you have this, right? And then, so you want to see, how good it is, right? So what you can do is you send in the golden data set, and so you essentially you execute the golden query itself, right? And you create a database. So you have these two databases, one created by the LLM SQL, your SQL coder, your LLM, and one is from the gold query. And then you simply you compare these two data frames,
Yeah.
right? So you compare the rows of these two data frames and see if they're identical or not. And if they are, that's correct, right? And if they're not, that's not correct. So
And we can tie the next question is a really good one, which ties into this is the idea with initial experiment design that you would not have ground truth when leveraging an LLM as a judge in the future. Curious what the utility of LLM as judge if you already have ground truth. And it's exactly that point that like we're trying to verify LLM as a judge so we can let it loose on data where we don't have ground truth.
right, exactly. And just to be clear, like this slide, this is another approach to evaluate your SQL coder. We are not using any LLM here per se. Like you're literally just executing the query created by your SQL coder and executing the query from your golden query, like your golden database, and just like one-to-one compare the two data frames that were created and see if they're identical or not. So this is the more like grounded approach. You're not using any LLM as a judge in this approach,
Yeah.
right? So this is the sort of a new eval kind of an approach. But the idea really, just so that people don't get confused, I think the idea of this is we will use this to see how good LLM as a judge is. So LLM as a judge has its own predictions of correct, incorrect, and this approach has its own. So this is the ideal approach, right? You would always you would love to have, this always. But the point is you don't always have question and query, right?
Yeah.
So you can't always build these data sets for yourself. So the idea behind this experimentation is you use this more deterministic approach, and then you use it as a ground truth to see how good your LLM as a judge approach is. So I'll stop.
Yeah, that's exactly it. And LLM as a judge is very scalable, something you can use in production. And it, you get to the spot where you feel comfortable about it and you can actually use it quite a bit.
Yeah. And again, just to make the distribution nomenclature clearer, right? Because we got this question in our in-person event too. So the distribution itself is maybe I'll give you an example. So let's say this, right? Let's say you had two queries here, whatever the query was, and you executed these two queries, right? So you get these two data frames. And so we literally compare these two data frames, and then, but the way we have sort of structured our comparison is that we don't look at column names of these, because sometimes the column names might be different. Your generated query might be, just defaulting to some other column names and all that. But we look at, each column, compare it to other columns and see if there is a match, and if there is a match for every column, then we say that these two are, they're identical data frames. So this is the approach that we were talking about here, like comparing these two data frames, just to make it extremely clear. And any questions, happy to answer those.
Yeah, there's a question. Do I need to build my own golden date questions and inquiries? I think that's kind of only needed if you want to retest Manas's results here. Like if you want, like I almost feel like the better thing to do is, if you do, and it really comes down to, are you using, are you doing Gen AI SQL generation? If you're doing Gen AI SQL generation, then I would just, I think the results will kind of speak for themselves. LLM-as-a-Judge. You might want to just start using it on your data and maybe, maybe use explanations to weed out the reasons that it's wrong. So you'll get to the end here. You can make a call whether you trust this and you want to, run with it, or you want to build your own gut check that his work is good.
Yeah, exactly.
Cool.
Okay, so let me let me minimize this thing. Very distracting. 1 second. Okay, so again, I'll summarize again. So what is all this? So we want to test the accuracy of LLM as a judge. So we have predictions from LLM as a judge, whether a SQL query generated was correct or not, right? We have that. That's our like predicted class. And then we also have predictions from our more deterministic approach where we are exactly comparing the data frames. So I would call it an actual class, like our ground truth, right? Because we are trying to see how accurate our LLM as a judge approach is. So you compare the outputs of the deterministic approach with the LLM as a judge approach, right? And then I drew like a confusion matrix to see like, what's like, how many times are we predicting the right thing through LLM as a judge? Now, it turns out like the F1 score is 70%. That's how many times it's correct. But what's really interesting, I think, is this space, right? Where your distribution, actually it's incorrect, but your LLM as a judge is saying it's correct, right? So it's not able to make the right prediction, and we'll get to why that is. But but this is the main result that we got. This is how accurate LLM as a judge approach is, with what we just mentioned, the kind of prompt we just mentioned. This is where it stands.
One of the questions from Cyan 10 is for data frames with millions of rows, isn't the distribution comparison too expensive computationally? And I think for us, I mean, the answer would be like, these kind of tests are offline to get you to a spot where you want to use LLM as a judge, but these aren't the things you're running in production. The thing you're running in production is just an LLM analysis. This is like the ground truth check.
Yeah, and just to add to it, I mean, I would argue, if you have to compare one row with one column with every other column, but you can optimize that search itself, right? Like once you have that match, you start eliminating the pairs, right? And that way you can optimize, the number of comparisons you have to do. So that takes down the cost,
Yeah, but I do think like,
Yeah.
because this is kind of like research to get to a spot to what you do in production, it's a little, just highlighting the research piece is kind of run once, which is the computational thing, and then it builds the confidence to run the LLM prompt that you have. Yeah.
This makes sense. Yep. Are there any other questions?
There's another one. Are you comparing the output data frame instead of the gen query versus golden query to account for the situation where the gen query is optimal but different from the golden query?
Yeah, that's exactly the point. So, and thank you for pointing it out. So the reason why we are not comparing the queries themselves and the output is because, ultimately the test is the output should be the same, and queries can be worded, like column names can change, and so that's why. Yeah, thank you for pointing that out. Yeah. Okay. All right. So now, we saw this, like some cases where your predicted class, your LLM as a judge says it's correct, but actually it's incorrect, right? So we'll get deeper into like these cases a little bit, but let's just look at a good case right now, when an issue. So what happens when an issue is caught? So this is our golden SQL, like, which is, from the database, like this should have been the main SQL, like, so what you're doing is, so the question is this, let's look at the question first. What's the difference in time between the first and last paper published, right? So we have this like publishing database with us, and we have time and everything around it. So the golden SQL says, the golden SQL meaning the one in the golden data set, it is max of this minus min of this as time difference, right? So it's calculating the time difference for you exactly. Whereas the one that our SQL coder creates, right? This is the generated one. It is, it's not giving you the difference. It's just giving you the first year and last year. So it's not answering the question, right? So the generated query is incorrect. So ideally, our LLM as a judge should say that it's incorrect, the generated query. So that's the expectation. Now, it turns out that's the case. So it says, of course, it identifies first and last year. However, it does not calculate the difference between these two. So this is where LLM as a judge shines. It knows the question. It's able to figure out that it's incorrect, and it makes the right prediction, right? So this is all good.
And then kind of bringing this all together for everyone. Imagine you're in production. You've got a SQL generation tool, maybe for a financial institution or something, and you have this other LLM-as-a-Judge evaluating those generations. So the LLM-as-a-Judge is looking over it and is catching, hey, this isn't the difference. And what's nice is we have an example in the library of Phoenix, but you just drop an explanation flag in, and you get a reason of why it thinks it's incorrect, which is what this is literally a copy and paste from the reason we got, which is kind of nice. It's kind of really is how it shines in my mind, like giving you the indication of what to go do.
Yeah, I agree as well.
Cool.
Okay, so that was all good. LLM as a judge did well, but now we get into like where does it make a mistake, LLM as a judge? So just to give you some context, the question was total number of citations by each author. So you have a lot of tables. It's so the database is called academics, within which you have like publication tables, citation tables, author table, and you have a bunch of tables in this. So that's the database we're working with. So to answer this question, total number of citations by each author, the generated query, which is like our SQL coder model working, right? It says, well, author ID, select author ID, because that's what you want. It does count of cite, which is good. But when it joins, right? So it has to join author and citation table. So when it joins, it joins author ID on cited. And cited, if you go to the like a data dictionary of this, cited is the publication ID. So it's joining author ID with publication ID, which if you know the database, it doesn't make sense, right? So it's doing that. Whereas if you look at the golden data set, it's doing it's using a little bit more tables, because that's what you need to do if you have if you need to join them, but it's doing the right joins. Then it's calculating the total number of citations. So as you can see, ideally LLM as a judge should say that this is not correct. The join is wrong. So again, just describing that. But LLM as a judge, it says the SQL query correctly solves the instruction. It joins the author and citation tables on author ID to get the total number of citations by, so it assumes that the cited is the author ID, and it says it's all like it all makes sense, which is not correct. So
And I think this is one where you look at it and you're like, well, if it had more schema information in the prompt or information on the table, like could have made the call a little better, right?
Exactly. So this is, and just to like go back to our previous discussion, right? A big assumption in the template itself was that assume that DB exists, and you know the schema. So and in some cases, if the table is very complex, it's very hard to figure out, even for us. Like if I would have not looked at the schema, I would not know what cited stands for, right? So if we can do this mistake, I don't think it's just, I think the lack of information within LLM as a judge is what is causing this like mispredictions. Yeah. Are there any questions? Because I guess this was one key point you wanted to sort of take up.
I think there's just someone made a comment, we were doing something sort of related. generated vectors for each row and in table database, including field definitions to make sense of the field tables. This is a good example of lack of information to make a choice. So
Yeah, that makes
great,
sense.
great.
That makes sense. I guess
Yeah, there's one other question. Is do you do any eval across several LLMs? We just did one in these tests right now. You could do multiple.
yeah, I think you could change your LLM as a judge, see how it does. But again, the moving pieces are so many, right? Then you can change the prompt, you change the LLM. So yeah, there are many ways to go about it.
Yeah.
Yeah. So I guess, Jason, this is a question for you too. Like, have you seen in practice if there are any any LLMs which are better LLM as a judge than other LLMs? Like, is there a ranking there?
Yeah, there absolutely is. And we actually do that for every pre-tested eval in our in the Phoenix document, the Rise Phoenix documentation, which is our open source kind of little library, has us, a list of tested LLMs against it. And so obviously the bigger models are better. So like, we're speaking closed models, think GPT-4 or Claude Opus are probably where I would land these days, but absolutely there is, it's like, it's good to have these golden data sets so you can kind of get a gut check of like how good that LLM you're using is at the task you're trying to apply it.
Yeah. And maybe we can share that later on too. But
Yeah.
I in my research came across a lot of golden data sets, like there is Spider, there is WikiSQL, DFog. So, there are bunch. There are also like domain specific golden data sets, like one for finance specifically. So, people can use them just if they want to.
Yeah, I guess a big shout out to the DFog open source team, because we heavily use the golden data sets to validate stuff here.
Sure.
Yeah.
Yeah. Okay. So this example, I'll again just minimize this. Okay. This example again, what's the average predicted time of graduation since admission in number of days? Right. So if you look at this, you're just asking time of graduation, right? So you're just calculating average of the difference as the time, and and the AI gen is doing the exact same thing, right? So it's just doing the exact same thing. So, but if you go back, if you go to the explanation of LLM as a judge, right, it says the query is incorrect. Whereas, ideally, if you see, the query is correct, it just matches the golden query exactly. So why it says this is interesting. It says the query is trying to calculate the average time to graduation by subtracting the admit term from this in the student table. However, these fields are in the data type, and subtracting them would not result in the number of semesters, right? So, so what it's doing is it's like it's hallucinating because we didn't give it all this information, when it's reasoning it out. But I think it's just like, it started creating these like, hey, there is this table, this is the schema for that. Which is another problem, right? If you let it assume, and if you don't ground it, then it starts making these like assumptions about what the data types might be, right?
Yeah.
So which again results in incorrect prediction. So yeah, that's another point we wanted to convey. Yeah. So, I mean, this was the crux of, the experimentation that we did. 70%, F1 score we got. And then, but there are like, we did some, like I did some further experimentation, and, ideally I should have got all of them in the presentation too. But, one way to improve this, and I saw a couple of questions around it too, is why not just put the schema in the template itself, right? Like just going back to the prompt template once, this, right? So let's not assume, and let's just put the schema within this eval template, right? And then let the LLM like see the database and then just figure out if the query is correct or not, right? So give it everything you got in terms of database and schema. So while I hoped that it would be, a better solution, but what happened was the schema, it just became too big. You're just dumping in every table description and every, database that you have in it, and hoping that it would, you know, extract the right information. But we know, like, for long context and for like extracting that information, needle in a haystack kind of a thing. LLMs are not, ideal. You need to tune them a lot through prompt or whatever to make them work that way. So, my sort of accuracy actually went down because, it started hallucinating and making like, more sort of not true predictions about the database, So that again, it didn't work, just putting your database schema in the template itself. So I guess something me and Jason discussed, like the future of sort of experiment, like future work in this could be where you extract, let's say you're talking about author database, author table, right? You only extract the schema of that table through maybe a RAG kind of a system, just retrieve the relevant schema and put that in the prompt template, so that your LLM has limited sort of information to work with and it can make more accurate predictions. So, you know, that's one of the key sort of future things, we can do. So yeah, but this was the experiment. This is what we found out. Happy to answer any questions about it.
Great. And I dropped some of the pre-tested evals in there. Let me just show I'll share this real quick just so the team can
Sure.
see what we mean by that. So there's some kind of pre-tested evals here on these. And we haven't got through, we're trying to add them to every pre-tested eval in here. But we'll kind of test it across models and give you an idea what the scores are relative to benchmarks. So we do our best to give you an idea, show you the templates, and then you can create your own. A lot of times you want to, I think this one we created our own template. Essentially it's just writing a template, and we started out, Manas started writing his SQL eval template by just, writing it here. So you start, these are places to start, which are again, just templates. And then the library itself, it's pretty fast. So yeah, so the library itself is pretty fast. And yeah, awesome. Cool.
Yeah, well, this was fun though.
Yeah.
It's working
out. Any other questions from the team? Is the LLM-as-a-Judge model a normal language model, not specialized text to SQL model? Yeah, that's correct. So LLM-as-a-Judge, almost all of them are going to be your larger models typically. Like we typically lean towards GPT-4 or Cloud Opus as kind of the test models. Gemini obviously as well. That set of larger models pretty good. And then normally you use a golden data set. If you want to use a smaller, faster model, your golden data set can help you understand how those will work on those. Cool. Yeah. So thank you all. Thank you, Manas, and congratulations on the Cal graduation coming up. And thank you all for joining us today. We do have one thing to note is we do have a Rise Observe in San Francisco, Chat 15, July 11th, with like an amazing set of presenters coming in evals. Lots of evals research going out there. What is the production use case for LLM-as-a-Judge? Okay, that's a good one. Yeah, and we have a ton. I would say most customers who are doing LLMs in production right now of any importance, like if anything's facing externally, your business, or anything is touching customers, customer service, bots, the response bots. LLM-as-a-Judge is just a way of scaling a performance metric is kind of the way I look at it. Like you have precision and accuracy in traditional ML, and eval is like that version for intelligent responses. You need intelligence to kind of evaluate intelligence, or LLMs to evaluate LLMs at scale. And so most teams I'm watching right now have this is for SQL generation, but if you're doing retrieval, or you're doing code gen, or you're doing summarization, you just need, or I have a customer who's doing like response for customer service, a bot that responds for customer service tickets. Anything you're doing, you gotta like, you can either have a human look at it, or you can have an LLM give you a proxy metric. And so this eval gives you a proxy metric for how well it's doing when you put it into the real world. Cool. Yeah, it's a great question. So we will do one. So we've been doing LM evals on so router-based architectures. I think there's one coming up soon. Evals for the probabilistic call of functions is something we've been running into a lot. Like router architectures call functions, how well it decides to call a function, if it's the right function to call. Some of those are parallel now, I might call multiple. There's a whole set of evals. I think a Gorilla LLM from Berkeley put out a set of evals on that. I think it's a Gorilla LLM team.
Yes.
And yeah, and so there's a whole, lots of our customers are challenged with routers and is it routing to the right place from a LLM perspective. So great question. And I think the team's presenting some stuff on that too. Cool. Awesome. What makes a judge better? Why can't you to self-evaluate? You can do, so we do that all the time. So the question is like, can you use a different LLM to judge an LLM results? And my comment on that would be, I see it all the time. And I wouldn't, I felt nervous in the beginning about like if there's something circular, like your comment, Manas's circular comment felt irrelevant in the beginning on that. Like am I generating something and then having the same thing evaluate itself? I think it comes down to the problem like it has more information than the original one. I mean, you felt the same thing, Manas.
Yeah,
Yeah.
exactly. So, I think it's one LLM you are tuning, even though prompt tuning,
Yeah.
to be able to like evaluate SQL. The other LLM, you're like specializing for creating SQL. So I think these two, especially because SQL is such a distinct task, it's very
Yeah.
well done by even smaller models, which are very well trained on just SQL generation tasks. So, we can separate the two out that way.
Yeah, and that's kind of what the golden data set gives you. It gives you some confidence that if you're generating with GPT-4 and then you're evaluating GPT-4, you have this golden data set that like gut checks whether that eval makes sense.
Yeah.
It says, so a couple more here. Prometheus 2, I don't know if we've tested that yet. I'm working on topic classification use case. Is there any open source version which I can test? Yeah, topic classification. So last week Wayfair did an eval discussion with us. So I catch that video. In that video, the model he had was topic classification for customer service. And he was building out evals on top of the classification, the labeling service that he had built. So he was moving from a traditional model to a LLM, Gen AI labeling, and then he built evals for labeling on top. So if you want to catch that session last week, and he used Phoenix and created custom evals for that. Why don't we assist our eval system with some deterministic code execution, filter incorrect queries with wrong join, hallucinated columns and tables? I don't know that one, Manas. Dude.
Yeah, I think, I think Abhishek is getting to the, this whole like, is there a way to bifurcate, right? Like maybe I'm interpreting this wrong, but our eval is non-deterministic because it's LLM driven. So can we have like a layer of like, have like more deterministic eval, like the one we showed, where one-to-one comparing, and then, just to take care of the issues of the other eval. So that's how I'm interpreting this, but maybe it's a different question.
That's a good question. And then does rephrasing or few shot examples affect your findings? I think few shots always good, right?
Yeah, I mean, few shots are good if, this is another future work, where can we extract like let's say you're doing like, a count kind of a query, right? So can we have a few shot of that kind of query, just to like make sure the LLM knows, the format, the syntax and everything, and then, so I guess that might work. Few short examples of that kind of query. So
yeah, and a query with a hallucinated column with results in an error wallet. So that was a question in I think our evals meetup that we had. Like what when it hallucinates a column, it gets an error, so we know for sure it's incorrect. Was kind of thinking about filtering those out for the judge, which is probably a good a good point.
Yeah, yeah.
Yeah, the errors give you an obviously an indication that yeah, that you it's not correct. But
Yeah.
yeah, and there's a question like would RAG help? Yeah, I don't know the time, don't know exactly the time with retrieval here. Retrieval is normally like the data you're trying to put in the context is bigger than the context you're trying to, or select some groups from
Right.
the,
Right.
but I'm not totally sure the time. But oh, with schema, yeah, with schema could like the goal would be, could you fit the whole schema? Did you started to test the schema stuff?
Yeah,
Yeah,
I did test the like dumping in the whole schema in there.
yeah,
But if you can only like somehow extract the right tables and that schema
yeah,
and put that in the LLM as a
yeah.
judge, that might be help it hallucinate less, So that's where I think should be is getting at.
Yeah, so there's a generation side and there's the eval side, and the eval one, you
Yeah.
probably, if you just pull the columns that are in the query itself versus the whole schema, you probably, yeah, you might get better results. So there's a couple variations of this we need to try. Yeah, cool. Well, thanks everyone. Definitely, if you want to run your own evals, check out the open source, the work that open source team is doing. They live in, they eat on stars, so give them a star if you use it and like it. All right.
All right. Thank you. Thank you so
Thank
much.
you.
Bye-bye.
Bye.